today I'm going to be biasing up a transistor amplifier. We'll design the circuit, and then I do have the components and I'm going to build it, and then we can hook it up to a signal generator and a oscope and see what it looks like. So this is a single transistor amplifier, so that's where we're going to start. I'm using a 3904 because I have like 50 of them. They're one of the most common varieties. And I do have a 5-volt power supply. That is somewhat of a design restriction. A lot of transistor amplifiers are designed to work at a higher voltage so you can get more rail-to-rail swing, but we're gonna make do because I think we'll be able to make it work out. And here's our, I'm gonna call this guy RC for collector resistor. Oh yeah, by the way, traditionally that's your base, the collector, and the emitter. I'm gonna put an emitter resistor on here, and we go to ground. And then on the base, we'll use a voltage divider to bias this thing. I just wrote plus V. It's the same as this one over here, you know. And finish out the voltage divider. Okay. Whenever we go and pick values for this thing, there's a few things to think about. We said we want to get, as best we can, like a rail-to-rail swing, so we want the output, which is going to end up being here. My 2N3904 is a little bit in the way. That's okay. We want, whenever there's no signal coming into this, let's call this Vn. We want the output to be sitting at about 2.5 volts, right? So, should I draw it? When there's no, if this is 5 volts, which is our maximum, if there's no input voltage, we want the output to be right in the middle so that when we do apply input voltage, it has the ability to swing all the way up to 5 and all the way down to 0, you know, at best. If it was sitting at 4 volts without an input voltage, then it would only be able to swing up to 5, and you know, your signal would get clipped. It would get clipped really hard. Also the same if it was too low. So that's what we'll shoot for. And here's the values that I picked. We have a 470 ohm resistor here and a 47 ohm here. These are fairly low, you know, 47, that's pretty low. I chose it because I wanted to make sure we have decent current out here, and whenever we calculate this current, the only thing limiting it, let's see, if we shoot for 5 milliamps as our collector to emitter resistance, then to determine what the collector to emitter voltage is, you would take 5 volts and then use Ohm's law to figure out how much each of these drop at 5 milliamps. And when we do that, we get about 2.65 volts. 2.65. which is cool. That's pretty close to 2.5. We also see that our gain, voltage gain, which is AV, is approximated by RC over, oops, this is RE, which is 470 over 47, or about 10. So we'll see how that plays out. And then for our voltage divider, we need to figure out where to put this, what voltage to put that at. We know this is going to be, that's just a diode in there, so it'll drop 0.7 volts above, about. And we can calculate here because it'll be 0 plus whatever this guy drops, and that turns out to be 235 millivolts. We'll just call it 240 millivolts. So 240 millivolts plus 0.7 volts, and we end up with about 0.94 volts here. And we'll just choose some values that give us approximately 1 volt. So I have a 3.9K and 1K. And whenever we do this, we also get approximately 1 milliamp flowing down through here, which is plenty. At 5 milliamps, assuming this guy has a beta of 100, we should see just 50 microamps flowing through the base, and so this is more than order of magnitude larger. That's fine. And yeah, let's build this thing. So here's a little breadboard I'll be using, and this is the power supply. It's actually a phone charger battery inside. There's a 18650 lithium ion, or it might be lithium iron, cell. And then this is a little adapter that I built that lets you plug in USB and then connect to whatever pins you want. In this case, I'll just be using the 5 volts and ground. So I'm going to collect my components now. Alright, this is the system that I use. It's not perfect. Some of the labels fall off. I believe I put them on with glue stick, so I'll have to work on that. Here's a 1K, so that's half of our voltage divider. Wow, that's really spirally. That's better. Alright, and what else? 47 ohms. Okay, cool. And no, I don't have a 3.9K here. Let's just see how a 4.7K works. I think it'll be pretty close. Got my 4 resistors. Oh, let's not forget the 3904. Alright, there it is. I'm just gonna put this guy in there. Here's our 470. It's emitter base collector from left to right. So if that's the collector, then the 470 is our collector resistor coming from the 5 volts. And then the 47 is the emitter resistor going to ground. we'll set up our voltage divider on the base, which is the middle pin. So the 1K from ground to base. And, oh, I put in the wrong resistor there. This is the 47. This other one is a 4.7K. That's the one I switched out for the 3.9K. And that also comes from 5 volts and goes to the base. Oh, you know what? This will be on the emitter. Okay. And I'll need something to push in there to connect up the battery. You know what? I'm using this ground rail. And the last thing is, on the input and output, I'm actually going to attach some coupling caps. So here and here. And for both of those, let's just do 100 microfarads. So that will remove any DC component from the circuit. Let's get our 100. Oh, see, the labels fell off, but that's too bad. Got these. These are 100 microfarads. I'm just gonna, might have to. Okay, so the positive side of the capacitor should be facing the input. And that's pretty much for both cases. That's pretty cramped in there. I might have to get a little jumper. Here we go. Okay. Cool. So that one in the wrong place. Realize I put that on the emitter. We have to have it go into the base. Still pretty cramped. That's a little longer than I was hoping for, but okay. Well, I'm going to fire up my DS1102E